I hope you have gained a fair amount of understanding about Redshift architecture. Let's talk a little bit of Redshift cluster management, which falls in the category of Redshift infrastructure handling. The first thing that I want to talk about is resizing a cluster. Now the question is, why would you want to resize a cluster? So let's say I have a cluster with 4 DC2.8x large nodes. Why do you want to change that? The reason is, let's say you need more processing power. So let's say you have a case wherein 4 nodes of DC2.8x large is not enough to process the queries, because the amount of data that you are processing, or the queries that you are running in those nodes, are very complex. So you need more parallelism and more processing power so that you can run the queries faster and meet your SLA. So in that case, you'd like to increase the size of the nodes so that you get more processing power, more slices, and more parallelism, or more parallel processing. So in that case, you'd like to resize your cluster. You'd like to increase the size of your cluster. Similarly, you may want to reduce the size of your cluster also, because let's say you have over provisioned, or for a certain portion in a month you do not need that much processing power. You need good amount of processing power, let's say during the end week of a month, but for the first 3 weeks you do not need that much, because you do not run those many queries. At the end week of a month, you run a lot of reports on Redshift, so you need more nodes or more processing power only in the last week. And when the last week is over and you step into a new month, you do not need that much nodes, and you want to reduce the number of nodes so that the cost is saved. So in that case also, we'll do a resize. We'll reduce the node numbers. So that's what resizing is needed, and this process is same for RA3 nodes also. If you want to increase the processing power, you can add RA3 nodes to your cluster, or remove RA3 nodes from your cluster if you do not need that much processing power. As we have two different architectures in DC2 and RA3, in RA3 we have separation of compute and storage. For that reason, the resize process is not similar, so it's a little different. There's one more reason you would like to resize. Let's say you want to change the node type. Let's say you want to change from DC2 to RA3. In that case also, you'd use a resize cluster. Okay, so there are two types of resize. The first one is elastic resize. Using elastic resize, you can add nodes or you can remove nodes, and you can change the node type also, as I said, from let's say DC2 to RA3. And elastic resize completes very quickly, typically within 10 minutes. And what happens is that the data slices are redistributed, meaning let's say you have 16 slices now, and after the resizing you have 32 slices, and your data size is let's say 16 terabytes. So earlier what was happening, each slice was handling 1 terabyte of data. Now you have two slices to handle the same 1 terabyte of data. So that's why the data slices are redistributed, meaning the data or the subset of data would be redistributed among the slices. This is the first operation. So let's say you are adding or removing nodes. The node type is RA3. You are not changing the node type. The node type remains the same. You are only adding or removing nodes. And as your storage is separate, there's nothing much that we're doing in the storage side. So what is the process in this resize? What happens is that Redshift first takes the snapshot of the cluster of the Redshift managed storage, which is nothing but the combination of the local nodes or the local SSD storage, which is attached to the RA3 node, plus the S3 storage. So it will take a snapshot. Snapshot typically completes quickly. If it does not, the resize can fail. So if the snapshot does not complete within a few minutes, then the resize can fail, can result in failure. Now, why it takes so less time? Because Redshift does incremental snapshot, which we'll talk about later on. After the snapshot is taken, the cluster metadata is migrated, because what we are doing is, let's say we are changing the node numbers. Because we are changing the node numbers, the number of slices would also change. So because of that, the metadata of the cluster is changing. because the number of nodes are different, the number of slices are different. Now what will happen is that the same slice would not handle the same subset of data. That will change. So what it will do is that it will migrate the cluster metadata, and during this migration the cluster is unavailable for a few minutes, not for too long but for a few minutes. Queries are temporarily paused. You cannot run any queries on the Redshift cluster, and the connections are held open, meaning connections are not closed. They are open, but you cannot run any queries using those connections because the cluster is not available for a few minutes. As Redshift changes the cluster metadata, that's why this is not available for a few minutes. Now, after this process is done, the data is redistributed to the node slices. So again, as I said, so let's say you have 16 terabytes of data. Earlier you had 16 slices, now you have 32 slices. So the data would be, or the subset of data would be redistributed to the node slices. Earlier a single slice might be handling 1 terabyte of data. Now a single slice would handle 500 GB of data. Now in this stage, the cluster is available for both reads and writes, and you have the RA3 nodes available, and the number of nodes have changed. Either you are increasing or decreasing, the process is same. So in this case, using elastic resize, what we have done, we have done an in-place resize where the node type has not changed and the queries and the sessions are held. They are not closed. The process that I have just described is called an in-place resize, because we have kept the node type same. Initially it was RA3 and finally also it is RA3, only the node count has changed. In elastic resize, when we change the node type, say let's say we are going from DC2 to RA3, the process is same, but a new cluster is created and the queries are dropped. So let's see the process. So let's say this is Redshift cluster DC2 and this is DC2 type. So Redshift will take a snapshot and resize can fail if the snapshot is not completed within a few minutes. It remains the same. And then instead of migrating the metadata, it will migrate the cluster data. Why? Because we are changing from DC2 to RA3. Now in DC2, all the data would remain in the local SSD storage. There is no extended storage that is in S3. So it is in local SSD storage which are attached to the compute nodes, to the DC2 nodes. As you are changing the node type, in RA3 the storage is different. In RA3 in compute nodes we have local SSD storage plus we have storage in S3 managed by Redshift or Redshift managed storage or RMS. So that's why the entire data is migrated. So as data is migrated, obviously metadata would also be migrated. Now during this phase, cluster is available only for reads. You cannot write, you cannot do any modification. Some queries are temporarily paused, but the connections are held open. So for a very small duration, even the read queries are paused, but the connections would be open. And then it is restored to the Redshift cluster with RA3 node type. Now after the restoration is done, the endpoint would be updated. The connection to the source cluster, which is the DC2 cluster, which is this one, will be dropped, and an event notification would be sent. So this is what elastic resize is. You can do an in-place resize when you are not changing the node type. When you change the node type, a new cluster is created which is not in place. So that's what elastic resize is. Now, when you do elastic resize, there are certain limitations. So let's say you have an original node type of RA3.16x large. You can increase the node count to 4x only. So let's say currently you have 4 nodes of node type RA3.16x large. You can make it to 16. Let's say if you have 6 nodes, you can make it to 24. It cannot go beyond 4x. Same is the case with RA3.4x large. If you have RA3.XL plus large and you want to increase the node count, it cannot go beyond 2x. So let's say you have 4 nodes, you cannot go beyond 8 nodes. You cannot resize more than 8 nodes. So if you have, let's say, 10 nodes, you cannot resize or increase the node count more than 20. In case of DC2.8x large and DC2.large node type, if you are using elastic resize, you cannot add node count more than 2x. Same is the case with reducing the node count also. So this is the growth limit. Then we have reduction limit also. Reduction limit means that you cannot reduce more than this. So let's say currently you have 20 nodes for RA3 8x large, you cannot reduce it to more than 1/4. So from 20, the minimum that you can reduce is 5, not less than that. Same is the case with RA3.4x large and RA3.XL plus. In case of DC2 nodes, it is half. So let's say you have 20 nodes, you cannot reduce it to less than 10. Or if you have, let's say, 30 nodes, you cannot reduce it to less than 15 because that is the reduction limit. The next one is classic resize, which is the previous version of resize and it is still available. We use classic resize when some of the resizes are not supported by elastic resize. Now, which kind of resizing is not supported by elastic resize? Don't worry about it, because when you try to do a resize, let's say if elastic resize is not allowed, then in that case you have to do classic resize. As simple as that. You do not have to remember this. Obviously, using classic resize also, you can add or remove nodes. Now let's say you have a source Redshift cluster. What you do is that you migrate the data to a target Redshift cluster. This is the format of classic resize. We have a source Redshift cluster and a target Redshift cluster, and we'll migrate the data. There is no in-place upgrade in classic resize. So it has to be migrated from one cluster to another. Now let's say the target Redshift cluster is not RA3. Right, so let's say you have source Redshift cluster is DC2, the target is also DC2. You are adding nodes in a DC2 cluster using classic resize. Let's say you have 4 nodes of DC2.large, you want to change it to 8 nodes of DC2.large. So that means the target Redshift cluster is not RA3. What is the process? So first it sends an event notification, then Redshift would restart the cluster. And after restart, the database is made read only. You cannot write anything, and it closes all the connections. During the migration process, the database remains read only. You cannot write anything. And after the migration is complete, the endpoint is updated. Connections to the source clusters are dropped, which is this one, but connections to this cluster would be open, the target cluster, and then it sends an event notification. Very simple, very straightforward. Now the second option is if the target Redshift cluster is RA3. So you're using classic resize wherein let's say the source cluster is in DC2 and the target cluster is RA3. So what is the process? Again, it will restart the cluster, but the database is available for both reads and writes. Okay, and then it will close all the connections. Database would remain available for reads and writes. You'll have to open new connections during the migration process. Once the connections are closed, you'll have to reconnect to the cluster, and your database would be available for both reads and writes. Then once the migration of data is done, the endpoint is updated, connection to the source clusters are dropped because you have a target cluster now, and an event notification would be sent. So this is what a classic resize is. So if you see, there's no in-place resize. In all the cases, there will be a source cluster, a target cluster would be created, and the data would be migrated. Let's say the source is DC2 with 4 nodes, and you want to increase the node count to 8. So the target is also DC2 and not RA3. It will migrate the data in this process, using this process rather. And let's say the source is RA3 or source is DC2 and the target is RA3. Then the process is this one. It is more or less similar. The only difference is that the target is not RA3. The database is available only for read, and if the target is RA3, the database is available for both reads and writes.